Now let us study the sequence impedance and sequence network. See, any network is there, it is having the impedance. Depending upon the supply and depending upon the circuit, it is been divided. And when a current flow through the circuit, that time what happen? Voltage drops and there is a impedance. Every circuit has the resistance. It is has the resistance, and due to that one resistance, impedance will be there. So it depends upon the balanced network, unbalanced network. So when the current it is flowing in the balanced network, when a positive sequence current means it is a balanced current, r1 r ryb current, ryb current will be same in this one. That time that impedance it is called as a positive sequence current. And when a negative sequence current is present, means unbalanced current, when the unbalance or phase displacement between R and Y and B is different. It is same, but the sequence changes. It flows in anti-clockwise direction. When it flows through the impedance, then it is called as a negative sequence current. And during the zero sequence, when a zero current sequence current flows through the network, then that is called as the impedance to a zero sequence current. So it is divided into many terms. The sequences, that is positive sequence impedance, negative sequence impedance, and zero sequence impedance. So analysis of symmetrical fault is very important. We have to find out the symmetrical component, like component VA1, VA2, like positive sequence, negative sequence, or zero sequence. So when during the balanced circuit we have to find, and when it is unbalanced circuit you have to find what is a positive sequence, negative sequence, as well as a zero sequence. So it completely depend upon the current which is flowing, and the network, which the network, how the network is there, then we can analyze is what is the impedance and what is the symmetrical component. Now we will move towards the sequence network of unloaded generator. See here, this is an unloaded generator. Okay, you can see this is a generator, unloaded generator. It is not loaded and it is supplying a current of IA1, IA, IB, IC. It is having the impedance. These are the impedance of the three phases, and this one it is connected to the neutral. It is connected to the ground. This is a neutral point and this is a ground point. It is connected to the ground through the reactor. This is a reactor. When the current when the generator is working, that time it supplies the current IA, IB, IC. That is, it is in the phase and it is in the balance network. It is in the balance network. So this one, what happened, it is in the balance network. That system, it is called as a positive sequence network. Now this three phase circuit has to be converted into a single equivalent circuit, a single equivalent circuit, and we have to find out the positive sequence, the negative sequence, and the zero sequence of this one. A balanced network we have to find out. Now you see the balance network of this one. This is a balanced network. We can see this is a balanced network. If you see this one, if you see this one, this is the first, this is a positive sequence current flowing. This is what happen, it is in the phase or it is in the balance. When it is in the positive sequence, that time a EMF is generated, so we have to represent this EMF, this three EMF we have to represent, and it is a giving supply IA1, IA1, IB1, IC1. One means it is a positive sequence network. So now we have to convert this into a single phase equivalent circuit. So I have converted this positive sequence, three phase positive sequence, into a single phase positive sequence. For this we will be having only one EMF, Z1, one impedance, and this is VA1 voltage, positive sequence voltage, and positive sequence current is there for this current. Now this reference bus is nothing but this is a neutral wire getting connected to ground. This is called as a reference bus. Second, this is a negative sequence. In a negative sequence, if you see negative sequence, we don't have EMF. We have to remove the EMF. If you remove the EMF, then it is called as a negative sequence current path. So IA2, IB2, IC2. Then I have to convert this into a EMF. What we have to convert in this into a single phase circuit. This is a single phase circuit Z2, VA2, IA2. This is a reference point. This is a reference point. Now the third, what you see the third, it is a zero sequence. It is a zero sequence network. Here also EMF is not present, and we have to connect this neutral path, the neutral path. And in this one, IA0, IB0, IC0, we have to convert into a single phase network. So it gets split up, it gets divided. It's get divided Zn and Z0, because we have to consider this also, not only this also and this also, we have to consider this two impedance we have to consider for this one. Now in this what happens in this one we have to, this all three are there, okay, this all three are there. Now I have to find voltage, I have to find va1, va2 and va0. So voltage of this one, so if you see, this is va1 is nothing but minus va ea minus IA1 Z1 by using Thevenin's EMF equation, or KVL. Sorry, we have to use KVL. When we use this KVL, then we can find out that is VA1 is equal to EA minus IA1 Z1. Next, this if you take VA2 is nothing but is equal to minus I minus IA2 Z2, that is KVL. We have to apply KVL to the circuit. We have to find, this is last one. This is when you use this one VA0, that is nothing but minus IA0 Z0. We can see this one. These are the three equation we are getting. By using the three equation, we can find this positive, positive, negative and zero sequence voltage. See now what happened, we have to find the positive and negative sequence network. I already mentioned that positive sequence network consists of a EMF and impedance, whereas the negative sequence consists of only impedance. So now we will be discussing how to convert a positive sequence into the negative sequence. And in this one, a three-phase synchronous generator and motor, they both have the internal voltage for the positive sequence. So we have to design. Now in this one, if you see this one, the first point, this is the diagram. This is a diagram, or we can say this is a diagram. This is a diagram, and in this diagram, this is a positive sequence. The positive sequence is there. Positive sequence, we can see EMF is there, and this is a Z impedance. It is a positive sequence. Now I want to convert this positive sequence into the negative sequence. I want to convert this positive sequence into negative sequence. So what I will do, in this one positive sequence, there is impedance is there and EMF is there. Current is flowing. Current is flowing. You have a neutral point also here. A neutral point also you are having. That time the most this is the reference line. This particularly this line, one line which is connected from the neutral to the ground. It is called as a reference point. Now I will convert this positive sequence into negative sequence. For that one, what happen, I will remove this EMF. If I remove this EMF, if I remove this EMF, then this becomes a negative sequence. So negative sequence consists of impedance, and the current will be flowing in this.